and what it does, it will do phagocytosis, which means it will eat other cells. Microglial. Last one of the CNS, oligodendrocyte, surrounds the axon. It provides myelin sheath. Okay, so right here, provide myelin sheath. Okay, so these are the oligodendrocytes. Okay, remember they jump. There's a gap there. This gap, remember the name of it is node of Ranvier. Node of Ranvier. Now, in the peripheral nervous system, we saw that there are two types of glial cells in the peripheral nervous system. First one is satellite cells. It's like support. Okay? Satellite cells, just think of it as astrocytes for the peripheral nervous system. They do the same thing, support. Schwann cells, which they wrap around and insulate also the axon. Okay, Schwann cells, unlike oligodendrocyte, they only wrap around one segment of the axon. Okay, one segment. The oligodendrocytes in the central nervous system surround the axons in the central nervous system, provide the myelin sheath, sends out many processes. Okay, even though Schwann cells and oligodendrocytes both insulate and in the myelin sheath. So here's that myelin sheath. Okay, so it wraps around like this. Okay, wraps around. Node of Ranvier, again, is that gap. So the unmyelinated part would be the gray matter. The myelinated part would be the white matter. Remember I told you, because it's got more fat, looks more whitish. Sometimes, if you are injured, sometimes your nerve does regenerate. Okay, it depends. Okay, so injury to the cell body will kill the neuron. Okay, so the cell body is here, it will kill it. But damaged peripheral axons can repair. So if you damage here, it can repair. After damage, the distal part deteriorates and is removed. The growth factor will stimulate the growth 3 to 4 millimeters per day. Okay? If this happened in the CNS, regeneration is less likely since oligodendrocytes do not proliferate. Okay, so it's more common in your peripheral nervous system. So here we have a brief picture of how your brain and spinal cord work together and sensation. So you turn on the faucet. Here's a stimulus. Okay, if it's strong enough, it's going to send a signal. So here's your spinal cord, actually, a cross-section of your spinal cord. Goes in, travel up to the brain, okay? And then it will cross over, called decussate, okay? And then an interaction will happen, okay? Whatever process is, your brain says, gives a response, and it's going to come down to the spinal cord again, to the motor section, to your hand. And whether you pull your hand away or not, it depends on how strong the stimuli is. So first, the hand sensation by thermoreceptor can change the electrical state. The amount of change depending on the strength of the stimuli. Okay, it's called graded potential. Graded potential is a local change in the membrane potential. Okay. Now, if you reach the threshold, you get an action potential. Remember, action potential is when the electrical signal happening and then it will go on. Okay, at the end of the unipolar axon, the electrical changes causes a release in the chemical, which is neurotransmitter. Okay, so the neurotransmitter, this crosses the synapse and binding receptor, causing this new neuron to change electrically and starts its own action potential. Then reaches the brain in the thalamus right here. It relays to the cerebral cortex, which is the outside. Okay, and then your body will say, hey, how does this feel? Now that you are aware of it, what if the temperature is not perfect, too hot or too cold? Technically, this is a notice from the upper motor neuron of the prefrontal gyrus. Okay, and it moves down the spinal cord and synapse with the lower motor neurons. Okay, this will tell your supinator and pronator whether to turn the arm up or down. Remember pronator and supinator? Okay, here, so that was a brief description of how it works. Now we're going to look at the action potential part. Okay, do you guys remember we talked about action potential? That's the electrical signal that travels through. Okay, so one of the key ingredients for this to work is sodium, potassium, and calcium. Okay, now this is very important. You have to remember this. Okay, there's more sodium on the outside, actually 10 times more on the outside. Okay, and there's more potassium on the inside. Okay, inside right here. Okay, most cells exhibit electrical property at the cell membrane. Outside the cell membrane is positive. You can see the positive, and inside is more negative. Okay, this means the cell membrane is polarized. Very important, this results in the difference in concentration of ions and permeability of the membrane. Okay, so what's going to happen? Moving ion cause electrical changes. Okay, you guys remember when the acetylcholine comes in, acetylcholine, which is a neurotransmitter, okay, it causes these gates to open. Okay, these gates to open, well, this is called ligated gate, ionotropic open, and when a signaling molecule bind, signaling molecule is the neurotransmitter. Okay. Okay, as you can see here, the neurotransmitter is the ligand. Okay, ligand. Okay, ligand is required, so it comes in, attaches to the receptor site, and then the gate will open. Now, what happened? Remember, outside there's 10 times more sodium. Once it opens, sodium will rush in. All right, potassium will rush out because it wants to reach homeostasis. Okay, because of that rushing in. Okay, the inside of the cell is usually about minus 70 millivolt, minus 70. When more positive rush in, it almost reaches positive 30 millivolt. So as positive goes in, it's going to reach, closer to 0, and then it reaches all the way to positive 30. Okay, that is called depolarization. Depolarization. So after it reaches a certain certain voltage, then a voltage gate is open, another one is open, and then potassium will start to leave the cells, making it more negative again. Okay? So at first, sodium rush in, then later on, potassium will rush out, because potassium is also positive. Another type of gate, so this is called a ligand gated, which means it needs a neurotransmitter. This is called a mechanically gated channel, typically a touch receptor, okay, with pressure or temperature. It will change and open all these up. Here's that voltage gated I talked about. When if the electrical property of the membrane changes, remember the inside is negative, okay, it becomes less negative if things start coming in. So this is that voltage gated. It will open for potassium to leave that we saw earlier. Even more different types of channel called a leak channel. Okay. Just randomly open. Membrane potential. You're going to see this a lot